There we go. Okay. Alrighty, everyone. So today we're going to be going over this 6.4 note sheet. And it's going to be over exponential functions and how to graph them. Same with logarithmic functions. So generally, an exponential function is going to look something like this. Y equals b to the x. That's like the most basic form of it. Okay? Its graph most commonly will always hit at most commonly will hit at x equals 0, y equals 1. That's where it's commonly going to equal. And then it's going to have it's going to look a lot like this, right? Right, Drake?
Oh, yes.
It's going to look like this? Right. Yeah, good job. And then remember we're going to have, it starts with an A. We're going to have an what right along here. What are we going to have over here? Starts with an A. Yeah, asymptote. Right. Right along the x equals 0, or y equals 0 axis, or otherwise known as the x-axis as well. So that's what that graph looks like. The domain, exponential functions, What's the domain for exponential functions? What's the domain for exponential functions? Anyone? What's the domain for exponential functions? X is, could it be all real numbers? Right, yeah, all real numbers. Every possible x, all real numbers. Right. What's my range, or all the possible y values? Oh, my bad. What are all the possible y values? Nick, do you have an idea? What are all the possible y values? No? So, if I look at the graph, do I notice, is there anything going to be below this, y equals 0? Is there anything going to be below it? No? So, the range is just going to be y greater than 0. That's just what it's going to be. And then we say like this, there's horizontal asymptote, kind of a shortcut, just writing out horizontal asymptote because it's a lot, and mathematicians don't want to write out a lot. It's just putting HA. It means the same thing, horizontal asymptote. And where is that going to be at? Y equals, here's the line right down here. So it'll be y equals, in this case, y equals 0, right? Now a logarithmic function, so there's all your basic things about an exponential function. A logarithmic function, it's going to look like y equals log base b of x. That's what it's going to look like. Okay? A logarithmic function is normally going to hit at x at the point x1, y0. That's normally where it's going to hit. And it's going to look a lot like this. Okay? I curved up a little too much. It's going to look a lot like this. Okay? So here, we're actually going to have a vertical asymptote. So an asymptote going up and down on the y equals, or no, on the x equals 0. A vertical asymptote there. So a log function is going to have the domain, because of that, it's going to have the domain of x greater than 0. And it's going to have the range of all real numbers. Now, if I notice something, and I'm being particularly astute, I noticed that with my exponential functions, my domain was all real numbers, and with and my range is all real numbers. That's something I noticed. Okay? So you guys notice how that's kind of flipped. My domain and my range are my domain and range, they trade places, essentially, between logarithmic and exponential functions. So because of that, these are going to be inverse functions. Another way you can kind of visualize that is that there's going to be a mirror image across this line, y equals x. It's going to reflect across those lines. We good?
Yeah,
we're ready?
Yeah, we're ready.
Okay, good. I like to hear that. That's where it's going to be, okay? Are there any questions about the difference between those? Another way you can kind of think about this, so like a t-chart, x and y, of an exponential. So like if we have, on an exponential, we have 0, 1. On a log, we're going to have 1, 0. They're just going to flip. The x values are going to flip, and same with the y values. They're just going to trade places. That's all that's going to happen. Okay? Any questions about any of that? Okay. If not, moving down here to the core concepts, there's different things that this graph can go. It can be a horizontal stretch, and it shows you things like right down here. These things show you what goes on. So if it gets to move 3 units to the right, it's going to be the opposite. Remember how we talked about with all of our other chapters from the past, like this 4 to the x minus 3. That's just going to be 3 units to the right. As long as it's contained with the x, it's going to be a horizontal shift somehow, in some way. And it's always going to be the opposite of the way you think it's going to go. Okay? This plus k at the end, that's going to make it go up or down. Just like right here. That's how it shows you. Okay? This reflection, if it's up here with the x, then it's going to be over the y-axis. If it's down here by the 4, it's going to be over the x-axis. If we have a shrink, it's going to be up here, over here. Vertical shrink or horizontal shrink, it's going to be contained up by the x. Or a stretch, that's where it's going to be. And then we have a vertical shrink, or vertical stretch. It's going to be right here. Okay? Those are the numbers you have to worry about. Okay? Does that make sense to everyone? Yeah? Good? So pretty basic. That's just exponentials. All right? Now we're going to go over to logs. All right? A log function is going to be something like f of x equals log of x. That's what it's going to look like. Okay? It's going to work the same way. It's so nice. As long as it's contained with the x, it's going to be a horizontal translation. So in this case, it would go 4 units to the right. Here it would go 7 units to the left. Because remember, it's always the opposite direction of the way you think it's going to go. So that's how you tell. Okay? Vertical translation, so moving up or down, it looks just the same. Does the same thing. A reflection, if it's contained within the x, within, like by x, like it is here, that's going to be over the y-axis. If it's outside or not by the x, it's going to look something like that. It's going to be over the x-axis. Okay? If the negative's right there, over the x-axis. If we have this a contained by the x, that's when we get to our horizontal stretch or shrink. Right there. And if we have a vertical stretch or shrink, it's going to be out front. So right here. This is how it's going to look like. Okay? Stretch or shrink. It's just like the last chapters. We're not throwing any curveball at you. We've been talking about graphing all year long. It follows the exact same rules, okay? It just looks a little bit differently with a log and exponential. Does that make sense to everyone? Yeah? Okay. Just a little bit more, and then I'm going to quit talking at you and let you get going on your assignment. So they give you like this f of x right here. This is the parent graph. From here, you can kind of decide what happens with g of x. So here, I notice that this negative, where's it going to go? It's going to reflect. Is it going to reflect over the x or the y? It's contained by the x. So looking at my note sheet, if it's contained by the x, then it's going to go over the y-axis, right? Reflect over the y-axis. This 3, it's contained by the x, so I know it's going to be a horizontal. I know it's going to be a shrink of 1/3. This 4, what's it going to do? Is it going to make it go up by how many? 4. Right, that's what it's going to do. Okay? That's what's going to go on here. I can go on to GeoGebra, or not GeoGebra, Desmos, and show you guys how this works. You guys kind of need to figure out which way it goes, though. So we start off with this function. 1 divided by 5. One divided by 5, and then it's raised to the, what is it raised to? Raised to the x. So there's our parent function. And then we have translations to it. We have at the negative 3. I'm up here. Negative 3x, right? And then we add 4 to it. So did it do what we thought it was going to do? Yeah, it did, didn't it? It made it smaller, closer to the y-axis. It brought it up, and it even flipped it across the y-axis. So everything that we thought it was going to do, it did. So we're in the clear. Now log functions, this is our parent function here. What's this negative do? It's going to be a reflect over the what axis? X or Y? If I go up here, I notice that it's outside, not by the x, so it would be over the what axis? X-axis, right. This 3 makes it a vertical stretch. And then this negative 2, that's just going to be a horizontal shift of how many? I heard it. 2, which direction? Left or right? Which direction? Left or right? Here it's negative 2, so it would go the opposite direction that we think. Right. Good job. So yeah, that's how you do those. If I were to type this into Desmos, I'm going to show you how to do that here. This is helpful for your assignment, so I'd pay attention here. So there's this little keyboard button down here. And then over in functions, and then miscellaneous, you'll find log right down here. This is our log buttons, okay? So I'm going to show you. So we are given, first one we're given is y equals log. Where'd it go? What's my base? It's just common log. Log of x. So that's our original function. That's the function we started off with. And then we're given this function y equals -3 log x minus 2. That's what we're given for a function. Now, does that make sense? We said it flipped over the x-axis, which it did, and then it moved right too. So does that make sense for everyone? That that's what it kind of looks like? Play around with these. Desmos can be incredibly helpful here. Okay? Are there any questions from this this worksheet? Any questions? Okay, if not, you actually have an assignment on Big Ideas Math. So if you go to Canvas, you'll be able to get there. Okay? And then we can go get that Big Ideas Math assignment done. You guys have a solid bunch of time to get this done. So there really shouldn't be any reason to walk out with any homework, honestly. So let's get rocking and rolling.